Hey guys, welcome back to my channel. In today's video we are going to see how to solve this problem called longest subarray with some k, right? So we have seen the brute force solution and we have also seen for positive elements and for zeros, right? But in this video we are going to see for positive and negative elements. So basically let's say some elements are there in an array. We have to find the subarray. What is subarray? Again, I have explained in this video where I have explained the brute force solution. We have to find a subarray with some k. Let's say this is a subarray and the summation is k. We have to find the length of that array, right? But it should be the longest. So we have to basically find the longest length of subarray with some k, right? So before going into the approach, I would say it's a bit tricky approach, so I want you to focus maximum on this approach, right? So let's say there are some elements. I have given dots because I want you to think in a generic form, right? So let's say from the starting index till this index, the summation of all the elements is sum, right? And I want to find a subarray having summation k. So let's say there is some subarray here. From this index till the last index, the summation is k. So what is the value of this? What is the value of this? So what is the value of this question mark? Basically from here till this point, summation is sum, and from here till this point, summation is k. So of course here it will be sum minus k, right? So this is the intuition that we are going to apply, right? So we will keep on storing the prefix sum. If you don't know what is prefix sum, let's say 1 4 minus 1 0 6 4. This is an array and I'm going to store the prefix sum, right? Prefix sum is basically we are going to store summation of all the elements from the starting index till that particular index, right? So prefix sum of this point will be 1, prefix sum of this point will be summation from the starting index till this index, prefix sum of this index will be the summation of starting index till this index. Similarly, summation of all the elements from this index till this index will be stored here. Similarly for the other indices, right? So what I'm saying bro, k is given 5. I have to find a subarray using this prefix elements that has summation 5. Naturally what I am going to do, I'm going to stand, let's say here, right? So from starting index till this index, the summation is basically 10, and I have to find subarray having sum k, that is sum 5, right? A prefix some value that is storing 10 minus 5, which is basically 5 again, right? So I got this value here, 5 is here, which basically means, see, from here till this index, summation is 10. From here till this index, the summation is 5. So from here till this last point, the summation will be 5, right? So what I am basically saying, from here till this index, summation is 10, and I have found that from here till this index, summation is 5. So can I say this is a subarray that has summation 5, right? That's how we are going to solve this problem. So to find some k subarrays, find sum minus k is there in the prefix or not before him. So let's say these all are the elements, and from here till this point the summation is 5 and k is 2. It is given that k is 2. Search for sum minus k, basically 5 minus 2, so 3, and I got that 3 here. I got the 3 here. That means from the starting index till this index it is 3. So for sure, the summation of these elements will be 2, right? So we got a subarray. So that's how we are going to do for each indices, right? So for each index, check if sum minus k is existed in the array or not. If there is, we will take the length and then store the maximum length among all those lengths and then return the maximum length. So for that, we are using map. Map will store the summation as a key and index as a value, right? So we will search for a particular sum, let's say searching for 2, or we are searching for, let's say, 3 in this map. So search operation will take of one time complexity on an average, right? So that's the reason we are going for map. And if we got the sum, if we got 3, what I want in which index we got 3. Here I got 3 in this index, right? Basically from starting index till this index. So I'm going to store summation and the index value. So why we need this index? We need this index to calculate the length from our current position. Let's say this is I, and from that position here we got sum minus k. And then using these two pointers, we are going to get the length. So let's have a dry run on some example, right? So at first I'm going to maintain a sum and I'm going to maintain a max length. So at first summation will be 5 in the prefix sum and k is given 3, right? So I'm going to check for 2. Is there any 2 in the prefix sum? I can't find any 2 because 5 is the only sum that is present in the prefix sum, right? So I won't do anything. I will go ahead, right? So the sum is 5 and the max length is, at first let's say 0. So in this index 5 minus 2, the summation will be 3. So here 3 will be stored. And what I'm going to check, bro, I have to find 3. So I need to check for summation minus k, right? So summation is basically 3 minus 3. I have to check for 0. Can I say that this is a subarray with some k? Can I say that? Yes. So we have to deal this particular case separately, right? So if sum is equals to k, that means from the starting index till the current index, it's a subarray and the length will be current index plus 1. So here current index is 1. So 1 plus 1 will give 2. So the length is 1, 2, right? So I'm storing the length in max length 2, since 2 is greater than the previous max length, right, which was 0. So let's move forward. I'm standing here and now the summation will be 3 plus 2, that is 5, right? So till here it is 5. So I'm checking for sum minus k. I'm checking for 2. Is there any prefix sum 2 before me? I did not find any. So I won't do anything. I will go ahead with this. Now the summation will be 5 plus 0, which is 5 only. And I'm again checking for prefix sum 2 and I didn't find any. So please move forward. Right, moving forward, here sum will be 5 minus 1, which will be 4. So I'm checking for sum minus k, that is 4 minus 3, which is basically 1. Can I find 1 in these numbers? No, right? So let's store the sum here and move forward. So here summation will be 4 plus 4, that is 8, right? So 8 will come here and I'm going to check whether 8 minus 3 is there in the prefix sum or not. 8 minus 3 will give 5. Oh, I have found 5 here. I have found 5 here also. But here also 5 is there, right? But since I have to take the longest length, I'm taking this 5. Which basically means that if a number is already present I don't have to store it again and again. I don't have to do this, right? So in case s minus k is there multiple times, take the leftmost starting point, right? So this entire subarray will be having summation of k, which is 3. Let's see, minus 2 plus 2, which will give 0, plus 0, again 0, minus 1 plus 4, right? So these two will be giving 3. So this entire subarray gives 3 as the sum, right? Although there are multiple 5s, we took the leftmost one. So we are going to keep prefix sum using Hashmap, where key will be the sum with basically these values. So we are going to keep this prefix sum values inside a Hashmap, where the key will be prefix sum and value will be index, right? So let's look into the code right now. So I'm maintaining a prefix sum here, then max length and summation, and I'm iterating through all the elements, iterating through all the elements, and I am storing summation till the current index in sum. And then I'm checking for this condition. If summation, if sum is equals to k, that means, see, this condition, right? If sum is equals to k, length will be I plus 1, right? So max length will be storing max of max length and I plus 1, which is the current length. Basically from starting index till the ith index, the summation will be sum, and this summation is equals to k. So let's say 0, 1, 2, 3. I have found till here summation is k. So the length will be this index plus 1. Basically for this the length is 4, right? 3 plus 1, which is 4. So if sum is equals to k, then max length will be storing max of max length and I plus 1, right? And then I am taking the remainder, let's say sum minus k, and I am checking in the prefix map whether sum minus k is present or not. If it is not equals to prefix dot end, that means it is present. If it is present, how we are going to get the length? Int length is equals to I minus prefix sum of sum minus k. Basically the current index minus that index where we got sum minus k as the prefix sum. And then I'm storing the maximum length in max length. And here I'm doing something like prefix sum of sum that we got here will be this current index, right? So here we are storing that key value thing, where key will be sum and value will be the index, from which we extracted the index here and calculated the length, right? So that's how key value pair is being used. But there is an if condition, right? There is an if condition. What this says is basically if sum is already existing in the prefix sum. In this case, let's say sum is 5 and 5 is already existing in the prefix sum. So do I have to rewrite this 5 comma 0 to 5 comma 2? Do I have to do this? 5 comma 0 means sum comma index, right? So do I have to increase the index? No. Why? Because we have to take the leftmost starting point. Why? Because we have to take the longest subarray, right? So if there are two subarrays, this and this, having k sum, will I take this or this? I will take this, right? So that's the reason we will check if the summation is existing in the prefix sum or not. If it is not, then only we will update prefix sum of sum equals to I. Otherwise, we won't do anything, right? Because previously there is some sum having some index. We will say, bro, I don't have to update it. Let it be like that only because I have to find the longest length, right? So at the end, max length will be having the answer, and that's how we are going to solve this problem, right? So here the time complexity will be of n. Why? Because we are iterating n times, and space complexity will be of n because of this hash map, which will take of n space at the worst case, right? So that's it for the video. If you like the video, hit the like button, subscribe to our channel. Until next time, see ya.